Hi everyone. Today we are going to finish up chapter 10.1, comparing two proportions. Our objectives for today are to calculate the standardized test statistic and p-value for a test about a difference between two proportions. We're also going to perform a full significance test about a difference between two proportions. So before we get into all that, we are going to talk about something called pooling. So when you combine counts to get an overall proportion, we get this concept of pooling. And furthermore, whenever we have data from different sources or different groups, but believe that they really came from some same underlying population, we pool them together to get better estimates. This happens when we are calculating the standard error for this type of test. So here, p-hat pooled is defined as adding up your successes from both groups and dividing this by the sample size of both groups. In our textbook, it is referred to as pooled. However, on the new course description for the AP Statistics course, they use p-hat sub c to represent p-hat combined. So when you see p-hat sub c, think of combined, which is the same as pooled because that's all pooling is referring to. You're combining your two distinct groups into one. Now, with that said, we have our test statistic for a two-sample z-test right over here. All right, so please go ahead and pause that slide, and I want you to write that down. And then we will move on once you're ready. All right, so just a couple things to keep in mind. You need a pooled proportion when you are calculating this test statistic. And if you look in the denominator, we have some references to that p-hat sub c. So that pooled p-hat or that combined p-hat goes on the bottom. And the main reason why you're doing that is because you are using a null hypothesis that assumes p sub 1 and p sub 2 are equal. And when doing that, you use your pooled p-hat to get that standard error on the bottom. Notice n sub 1 and n sub 2 are different, but you do use that combined or pooled p-hat for the numerator of both of those fractions. And if you look at the formula sheet, this is what we use. The top formula is what we use for the confidence interval. This is the standard error for the confidence interval. Notice you do not use a pooled p-hat. You use a p-hat sub 1 and a p-hat sub 2, although you do use n1, n sub 1 and n sub 2. But when you are assuming p1 and p2 are equal, you use this. Now it doesn't look exactly like what we just took a look at, but if you distribute this entire quantity here to both of those fractions, you're going to notice that you get the exact same formula for that standard error. So this one would work as well as the slide that you saw, as well as the formula that you saw on the previous slide. All right, with that said, I am still going to encourage you for the first time to just kind of rely on your calculator. All right, because that formula can be tricky to use. And I'll show you how to use it and exactly what to write down when you take your AP exam. But basically, it's a two proportion or two prop z test. Okay, we will get into that more in detail in just a moment, but I am going to highly encourage that. And here is an AP exam tip from our textbook, and it just says that the two sample z statistic does lead to calculation errors by students. So that two prop z test feature can be used, and as long as you write certain things out like your test statistic and your p-value, you are more than welcome to use that, and it's totally acceptable. All right, so let's get to our first example here. So this is the same data from the problem about the students not eating breakfast when coming to school. So if you look vertically, we've got school 1 and we have school 2. Now, if you recall in that problem, school 1 had 19 of 80 students not eat breakfast on a particular day. And then it was 26 out of 150 that did not eat breakfast on another for that particular day for school 2. So our first question is, explain why the sample results would give some evidence for the alternative hypothesis. And just in case you've forgotten, we assumed the proportions of students not eating breakfast were equal. And the alternative for that problem was that the rates of students eating breakfast, not eating breakfast, were different in some way. So this is the alternative that we're curious about checking. All right, so we're going to talk about A, and then we're going to go ahead and calculate the standardized test statistic for B, as well as the p-value, and then we'll talk about our conclusion for part C. All right, so if you notice, again, 19 out of 80 is roughly about I would say about 23.75%, or in other words, 0.2. I'm having a lot of trouble writing this down here, but 0.2375. Let me write that again. So p hat sub 1 is 0.2375, whereas p hat sub 2 is 0.173. So you have about a 6% difference if you're thinking in terms of percentages. And as you can see here, that's about roughly 6% difference in that proportion, which does give some evidence in favor of a difference. Okay, so now for part B, calculate the standardized test statistic. So what I want you guys to do is hit Stat, Tests, and go over to number 6, which is the 2-prop z-test, the 2-proportion z-test. And as you can see here, you are going to input your quote-unquote success of 19, and your sample size 1, which is 80, and your successes for the second group, 26, and your sample size for the second group, 150. And you are going to mark the not equal to button right here, because that's what the alternative is claiming. And if you do all of that correctly, you are going to notice that you will have a z value, which is our test statistic. That's our z-score of 1.168. And this p-value right below it is about 0.24. Now, this is your p hat sub 1 as listed. And this is your p hat sub 2 as stated. And what is this other p? Well, that other p is your combined or your pooled p hat. Okay, so 0.1956 if you pool these two successes here, 19 plus 26, which is 45, and you divide it by 80 plus 150, you will get your pooled p hat of 0.19565. All right, but if you're using this test on the AP exam, you want to definitely write the test statistic and p-value. All right, our conclusion: because the p-value of 0.2420 is greater than alpha equal 0.05, we fail to reject. It is not low enough, the p-value being not low enough to reject HO. So it is not convincing evidence of a difference in the true proportions of students at School 1 and School 2 who skipped breakfast today. All right, one final problem here. I'm going to pause the slide and I want you to read through it as we don't have too much time here, but please go through it, and then we're going to answer questions A and B here. Do the results of the study give convincing evidence at the alpha equals 0.01 significance level that gemfibrozil is effective in preventing heart attacks? So please read that. Check back with us in about a minute. Okay, so this study was done with two groups of volunteers. One big group of volunteers, rather, and they were randomly assigned to two groups. A group of 2,051 men were assigned to take the drug gemfibrozil, and a second group of 2,030 men were assigned to take a placebo. 56 men of the 2,051 in group 1 experienced a heart attack 5 years later, and 84 of the 2,030 in group 2 experienced a heart attack 5 years later. All right, there's some more information on the study. Please go ahead and look at that if you're interested in this. All right, so here is the state portion. So our null hypothesis can begin with H naught, and we have the true proportion, that true heart attack rate of this gemfibrozil group is equal to the true heart attack rate of this placebo group. Remember, you don't have to write it as a difference. You can write it just like this. And your alternative can be written as P sub gem is less than P sub placebo. Now, remember, we want to see if this heart attack rate is less than the heart attack rate of the placebo group, because we want to see if that medication really is making the heart attack rate lower for the gemfibrozil group. All right, and notice how we write our parameters. The true heart attack rate for middle-aged men like these. Remember, we cannot overgeneralize here because we did not randomly sample from a population. These were volunteers. And same thing, middle-aged men like these. Don't forget your alpha level as well. Alpha equals 0.01. All right, so now our plan, this is called a two-sample z-test. If you call it a two-proportion z-test, as it's written in the calculator, it's not a big deal. They won't dock you any points for that. But that's the name. You have your random condition. These were volunteer subjects that were randomly assigned to either gemfibrozil or placebo. Your large counts condition, 56 quote-unquote successes in the first group, 1,995 failures in the first group, 84 successes in the second group, 1,946 failures in the second group. All are greater than or equal to 10. All right, now the do step. So you can find all the individual proportions individually here. This is the p hat sub gemfibrozil, p hat sub placebo, and this is our pooled or our combined p hat sub c. Okay, now if you want to calculate this by hand, be my guest, but it's totally acceptable to use your calculator as long as you give the test statistic and the p-value. Okay, so let's do that here before we run out of time. 2 prop z-test gives us a test statistic of negative 2.47. The p-value listed right below it is 0.0068. So those are what you want to write down if you are going to use this on the AP exam. So again, it's right down here. Just make sure you know the difference between all the P's here. So many different P's in statistics. And again, look at all the inputs and look at how everything was entered on the calculator, and be very careful. These numbers have to be total numbered counts. All right, so in conclusion, because our p-value of 0.0068 is less than alpha equals 0.01, we reject the null hypothesis. There is convincing evidence of a lower heart attack rate for middle-aged men like these who take gemfibrozil than for those who take only a placebo. So these are the kind of statistical tests that are used when approving medications and seeing if they're actually effective or not. All right, and there was another question on interpreting the p-value. I'm going to run out of time here, but please read through that. Pause the slideshow and just read through them. That's for part B. Okay, before we go, I wanted to talk to you guys about how to use Staplet to do what we just did right now. So go to Staplet, scroll all the way down to traditional inference, and go to 2 sample z-test for proportions. And if you type that in, notice I put heart attack here, and I put yes and no, gemfibrozil and placebo, 56, and I have to subtract 56 from the sample size to get 1,995. 84, I subtract 84 from the second group sample size to get 1946. Begin our analysis. Scroll all the way down here to the bottom and make sure you have all the correct notation. 2 sample z-test, alternative hypothesis, and you get your z